My name is Raul. I work in Zühlke Engineering. And my talk for today is about preventing death, DevOps 9600 success, meaning us helping build this application help save lives. There are some links at the end of the presentation that you can check out at your convenient time, where we showcase and explain how we came up with that number. Please, join me for a walk. That's why I was telling you before the presentation, let's go for a pizza and let's have a huddle here together, just like family. I'm into photography. This is a photography of mine. I'm into film photography, so you might see some of them. This is the first time we meet, so I thought of saying 5 things about myself you can get away with today. I was born and raised in Venezuela. I was in South America. I moved after high school to Barcelona, where I studied computer science. And I began consulting here at Zühlke in 2017. And I particularly like this picture because it's the first time we did Zühlke Camp, which is a week. We go out to a location and we sit for a week learning together and so on. And that week, we managed to invite Ken Beck. That's the first person sitting here on the side. Then we have Keith Breathwaite. I don't know if you ever heard about him, but a highly influential person in the space of agile software development. He has his talk around TDD as if you meant it. Very interesting talk. Further down, there's Steve Freeman, the author of Growing Object-Oriented Software Guided by Test. He used to work here before, well, both of them, Keith and Steve. So I love that year. I got to meet them and learn from such a highly influential people in the software engineering space. I became a lead engineer in 2022 when I set sales with the Zühlke team. We were selling in Croatia, so we also do fun stuff. And here I am today. I continue to grow. And this is a picture, film photography again, with 2 of my colleagues here in Zühlke. I can use this. So I wanted to ask you this. What would you do if you had to save this many lives? You have 12 weeks. What people would you invite? What roles? What expertise? What would be your architecture? What systems would you use to think about building such a complex, meeting such a complex mission? I can tell you we didn't know from the get-go how it was going to go, but we managed in 12 weeks. This goes the other way around. So I just asked you, who would you invite? We ended up inviting or having to work with, because it wasn't all on us. We work with policymakers, researchers, designers, engineers, as well as experts in security. The UK has their own security center. We had to work closely with them. They were monitoring our access, our API calls, everything. We were running on AWS. We had Slack, and there was a dedicated Slack channel to get every single move any of us would do on AWS, querying CloudTrail and stuff like that. We brought in people who would think about ethics, security, and was a big part of it, but also protecting privacy. It turns out that there is somewhere in the UK, I can't remember where a whole postcode is only used, I may be saying this a bit wrong, but it was something along these lines. One whole postcode identifies one town that only has like 10 houses. So if an application like this one was going to help you detect that you've been in close contact to somebody who was tested positive, you would immediately know. So there was no privacy there. So that was, for example, a thing that made us drive a change. So we only took the first part of the postcodes in the UK. And accessibility. User experience was a huge part of the application. We would start, a normal day for me would last 16 hours during those 12 weeks. But for different people, like the UXers, the researchers, in the morning, they would start with an idea and a plan. They would go and interview people, different backgrounds, ethnicity, and all of that. And then by the end of the day, the mobile engineers, they had to completely change the plan because they had learned a whole bunch of things that we needed to change everything. So this was the vision that the NHS told us about the application. We wanted to break the chains of COVID transmissions. We wanted to do this digitally and do contact tracing digitally. I think at the beginning, some countries or even the UK, some places were writing down names, time where you checked into a venue and stuff like that. That doesn't really scale, and that doesn't really help anybody understand how transmission is going and where areas of risks. So there were five main areas. We wanted to know people's COVID status, again, in a private way. We wanted to know the use cases in which they've been in contact with others. We wanted to notify people so that they can protect themselves and protect others. We wanted to provide accurate COVID-19 advice through the application as well, and encourage adherence to the rules, the government rules that were going on, what times you cannot be out and all those sort of things that were happening back in the day. What we didn't realize is that we were actually building a massive data system because we were collecting metrics of the kind user pressed button A, user checked in. I don't know if you remember, you would go with the application and you would check in with the QR code and the venues. So checking into a venue, that would be one flag up in some JSON file inside the mobile phone. And that generated a massive amount of data. There was a day when we roll out that stuff that, for some reason, all the mobile phones decided to sync with the server, with our server, and they sent the data back at 2 a.m. or 1 a.m. and our lambdas started throttling because we didn't account for all of that to come at the same time. We thought, because the app was meant to be distributed to keep things safe as well. So we thought, well, the things are going to come at a different random times. So that was a learning exercise then. That's all nice. The vision is all nice, but DevOps Meetup, I want to tell you something about DevOps and how basically this is more focused on the backend side. The mobile app had its delivery lifecycle, let's say, or development lifecycle. The backend had its own, and then the infrastructure, which is the team where I was part of, had its own. But DevOps is not just about is one of the things about DevOps is breaking silos and so on. So I was in the cloud infrastructure team. I did not sit there the whole entire time. I was running around virtually on Teams, on Slack, through different teams, communicating with different people, and enabling different developers and different teams be able to do things, quality assurance and so on. So really, during this time, who were DevOps? There were people who were doing operations, people who were doing development, like software engineering, security, government, architecture, compliance. The architecture, you can find it on a repository on GitHub. That's all available. Quality assurance was a big thing as well. So how do we support them? We were roughly 70, or a bit under 70 engineers of all different disciplines that needed to make sure that different things go out on time, within the scope, as promised, with all the changes that I was telling you, that in the morning there's one thing going on and in the afternoon a completely different thing is happening. The mobile apps were, one was written in Kotlin for Android, the other one was written in Swift for iOS. So you can imagine all the synchronicity that needed to happen. But today I want to focus on these three things. How do you enable these three sort of roles or capabilities to be efficient? So I want to ask you, how will you support rapid development of a solution that goes in the cloud? How do the teams in those three capabilities, they deliver quickly enough? What tools would you go for? What automation things? What checks? What tests? We won't have time to go through all of them, but I want to tell you a bit about the main one that stays close to me. But before I do that, I need to give you a bit of context. The system ended up being fairly big. There were a lot of other systems interacting with the core system. Again, this is available open sourced. But the main square there that says NHS CV19 app and cloud services over here, that's the main system that we built. It needed to exchange keys with Google and Apple. We actually had to be on the phone call with them and understand how to implement the what do you call it? Forgot. The principles, the APIs that they exposed for being able to make exposure notifications a reality. So how do you make this system alive? And how do you support everybody that is making this one system alive? Because everything else is just integrations. Eventually, we supported the analytics team, which were a big part. Microsoft and Accenture helped us there. The QR venues, which is the generation site, the site that would generate the QR codes for all venue owners, and that later on you would scan. We also ended up looking after that system. That started off with some other company, I can't remember the name. And at some point we also built the self-isolation payments because the government came up with a plan to be able to support people who were struggling financially. So we needed to have a bit of a connection with the mobile application. Once you've tested positive, then you can go through the journey and so on. Deep into what the COVID-19 system was, we go from the external interactors all the way inside to the cloud services and all the way how we share and exchange data. We're not going to go through all of this, but just to give you an idea, mental map of the system. Down here we have operations on the lower left corner. That's the team where I was sitting on, but I was supporting all the others. So I was telling you there is something close to me that I want to tell you about today, and it is bubbles. Have you heard about bubbles? Bubbles are similar to the characteristics that we see in microservices. And this is a concept that we started talking about more and more, and it came from us in the DevOps community, and we started kind of like sharing it with the engineering teams, the quality assurance teams, and everybody else. A bubble would be basically a subdomain inside a larger domain. First, a domain, an example is the application's backend, the analytics that I showed you before in separate box. We had something called the documenting reporting tool, which was a system and a mobile app, a website that we built internally to be able to collect all the information about the end-to-end UI tests that we were running on the mobile application. So the documenting reporting tool would give you statistics around that, and it will also give you some statistics about how the app and everything else is doing. Now these are domains, and these were deployable units on AWS. They had their own set of Terraform module, and they had their own software basically. A lot of them were Lambdas. The documenting reporting tool was a React application, for example, etc. So that's typically probably what you're used to. Then the cloud infrastructure, for example, is another whole domain, but that one had bubbles. The CI/CD how do we make CI/CD available to all the teams on all the different domains? And also for us in the cloud infrastructure team, how do we make CI/CDs for our code to be able to deploy infrastructure and so on? So one bubble to only take care of that. IAM, AWS IAM. How do you handle users, make change to roles and policies and so on? Part of it because of how Terraform modules work. So it was a bit driven by the technologies that we were using, but at the same time, we needed to have a way of deploying things without breaking other stuff. So we started using the concept of bubbles more and more. On software, we also have software on the cloud infrastructure side of things, like the alerting using AWS config rules and many more services. We created bubbles for them. Again, similar to microservices. When something becomes delicate enough, let's say, that you want to control it kind of like in an isolated manner, that you can have a release process for it, a new bubble would come to exist. Now, how do you enable then developers to build, test, deploy their solutions in the cloud, using all these bubbles, targeting just the one domain that they need and so on? As you know, automation helps you glue everything together. So we used a tool called Gaudi. Now Gaudi, probably anyone here will know what Gaudi is because it's not the typical tool that is super known out there. It's not in any famous page of any sorts, but a colleague of ours developed Gaudi out of years of experience. It's based on Ruby, and it's a build engineering tool. It allows you to codify your knowledge through software, through Ruby code, vanilla Ruby code. It's very simple. And it gives you a couple of things. And it's called Gaudi partially because he used to live in Barcelona like myself. And then he got inspired on Gaudi's architectural notions and vision. So that over there is Casa Batlló in Barcelona. Now, let me tell you, this is one thing I want you to live with tonight. The app was very nice, and we had a wonderful effort, but Gaudi, that was amazing. Consistent UI for every operation. UIs are not just websites. Your developers or your colleagues who are using automation tools, who are writing command lines, who are triggering those command lines as a user interface. Gaudi provides you with that. Secure conventions, very, very important. Standardizing, having conventions in a way that everybody kind of like adhere to all of that. This was super important. Why? The backend team had their own needs and their own software to deploy. The cloud infrastructure team, they also had their own problems, their own domain. But because everything was standardized enough through this tool, we were all talking the same language. And I'm not telling you language, Ruby language. We were talking, basically, I could change domain from the cloud infrastructure and go and help the backend team without no effort. When we had to bring in the QR code systems, the QR venue systems in, we brought Gaudi right away. The way this looks like is per repository, there would be a whole setup of Gaudi. It's just like a framework, it's just like a tool. Set it up in a directory and it starts automating things in a standardized way. Build engineering ABC, automate, build, and codify. We talk about this in a book that we released here at Zühlke, but really what build engineering should be about is three simple rules. We should be in a position to perform the same steps over and over and over, and anybody. We should always be able to build it, and if the server says no, the build server, stop and fix it. Everybody was doing this during the COVID-19, the development of the backend of the COVID-19 app. And the most important thing is codify your knowledge. As soon as you start writing Terraform apply, and then you need to do Terraform apply again, and you need to do Terraform apply again, or you need to, I don't know, submit or store some configuration management, configuration values in AWS, and you're gonna go and use the AWS CLI. Stop, codify your knowledge, commit it, maintain it, and apply all software delivery cycle that you know to it. Its use, basically it runs on any OS. The OS differences, Microsoft or Windows or Mac, Mac OS. They're all hidden. It's super stable. We've been using it for 3 years or so, and it's basically sustained major Ruby update versions because we're using very vanilla Ruby in there. And it's simple. CLI is a standardization. Its UI is self-documenting, which is amazing. You can ask to print out the documentation. Nowadays with ChatGPT and stuff like that, you can print out the documentation, upload it, and then ask more questions to the thing, right? It has its own developed life cycles. It's full, it's mature. You can modularize it. In Zühlke, we have assets that we've deployed of code as well that we use over and over, like Lambdas. Sometimes you have to zip them and package them and upload them to AWS, or Java code. Sometimes you need to create a zip and store it to be able to reuse it. All of this is there. And just one final note, really. How do you think the NHS benefited from successfully scaling all these digital operations and doing all this DevOps stuff? I don't know how many of you work with consultancies, but consultancy or not, there must be somebody someday you'll have to explain how your effort, how your outcomes are really benefiting the system that you're working for, the system that you're maintaining. And then I like what we did because it really fits in Dora. I think I'm a latecomer to this. I learned about Dora and the actual content of Dora earlier this year. And then I became fascinated by it, and I like how we really managed to do these things. We really managed to go, I'm saying faster time to revenue, but here revenue, we were not making money out of the thing, but we were really being able to tell the government, this is done, this can be used, and it was there. The technology was enabling us to go faster and even faster, especially like Ruby, Gaudi. We had real-time data-driven analytics that were coming through the work that we were doing, but also we were able to access the data analytics from the mobile itself, the mobile app. So I thought we managed to really get Dora in practice. So this is it. Together we managed to enable the delivery of a medically approved mobile app. That's not easy. You go through a lot of thorough investigation. So this is the story I want to tell you today. Thank you very much.